In this section, we're going to take a look at two important theorems. We're going to start by taking a look at something called Rolle's theorem, and then we're going to take a look at something called the mean value theorem. Let's start with the easier of the two, Rolle's theorem. Rolle's theorem says that if a function f is continuous on a closed interval ab and differentiable on an open interval ab, also if f at a is equal to f at b, then we are guaranteed at least one value in AV such that f prime at c is equal to 0. Right, and that might be absolute nonsense to you. So let's understand what all that really means before we go through and take a look at some examples of how to apply Rolle's theorem. Now we know what continuity is. Okay, continuity basically means we can trace the function, not lift up our pen. Okay, what does differentiable mean? Well, differentiable means that we take the derivative and every value on this interval AB exists, okay? And an example, just really quickly. We know that the square root of x, same thing as x to the 1/2, the derivative of that would be 1/2 x to the minus 1/2, or another way to write that is 1/2 roots of x. We know that this function is not differentiable at x equals 0 because we can't divide by 0. We know that this function is not differentiable at x equals -3 because you can't plug in a negative value into a square root, right? So when we talk about the idea of differentiability, we're really just looking at the domain of the derivative. That's probably the easiest way to think about it. So differentiable is really the domain of the derivative, right? Now there is some good news, okay? If the function that we're dealing with is a polynomial, then we don't even have to worry about that, right? And remember, a polynomial doesn't have any restrictions on the domain, and neither does its derivative, okay? So one thing to keep in mind is that all polynomial functions we'll say adhere to 1 and 2 of Rolle's theorem when we try to apply it. So it's just up to us to be able to apply the third one, f at a equals f at b, right? And our job is to say, okay, if all three of these are true, then we're going to find the derivative and find a value to where the derivative is equal to 0 as well. All right? So let's take a look at an example of this. So we have our Rolle's theorem, and we have this function, x minus 9 squared, on this interval, 0 to 9. All right? And first of all, we're going to go through and we're going to make sure that Rolle's theorem holds, at least the conditions. And then secondly, we're going to find any values that satisfy Rolle's theorem. All right, so let's take care of the conditions first. All right, so first of all, okay, is it continuous on the interval 0 to 9? So is it continuous on 0 to 9? All right, and of course it is, yes. And the reason is yes, because this is a polynomial function. Okay, so yes, f is polynomial. And we know polynomials are continuous over the domain of real numbers. Okay, is it differentiable on the interval from 0 to 9? And the good news is, once again, yes. Okay, because f is polynomial. All right, so if we have a polynomial, we're good for the first two conditions automatically. Right? Now the last condition, what is f at 0 and what is f at 9? All right, and remember, what we're trying to see is that f at a equals f at b. All right, so what is f at 0? Well, f at 0, we're going to substitute it directly back in, and that's going to be 0 times 0 minus 9 squared quantity, and that's clearly 0. F at 9 is 9 times 9 minus 9 square, which is 9 times 0 square, which is 0. And by multivariable calculus methods, 0 is equal to 0. So all three of these conditions hold. So right away, we know that we have to find the values. All right. Now, how do we find the values? Well, what we're going to do is we're just going to find the derivative and set the derivative equal to 0. Okay, so now remember our function. The original function is f at x is going to be equal to x minus 9 squared. Now, there's two ways to find the derivative of this. We could certainly use a product rule and a chain rule, but couldn't we just FOIL this out? Couldn't we just do some algebra magic and rewrite this as x minus 9, since it's squared, which is the same thing as x squared minus 9x times x minus 9. All right, so all I did was I just distributed the x, and you only want to multiply it once. Okay, it's sort of like if you were doing 3 times 3 times 4, that would be 9 times 4. It wouldn't be the same thing as 9 times 12. So we only distributed the first one, not to both of those. All right, so be careful with your algebra. Now we're going to FOIL this. So notice no derivative yet. We're just expanding. So x cubed minus 9x squared minus another 9x squared plus 81x. Okay, or in other words, our final expanded version is x cubed minus 18x squared plus 81x. Now we find the derivative. And remember, what we're asked is we are asked to be able to find all the values that say f prime at c is equal to 0. Okay, so derivative, really easy, right? 3x squared minus 36x plus 81. And we're going to set that equal to 0. Fortunately for us, whoever gave you the problem knows that everything is divisible by 3. So we're going to wind up with x squared minus 12x plus 27. And are there two numbers that multiply to be 27 and add up to negative 12? Yes, there are. And so finally, we end up with x equal 9 and x equal 3. All right, but we really don't care about 9. And the question is, well, why don't we care about 9? Well, 9 was already on the interval, right? We already know that it equals 0. All right, we also know 0's on that interval as well. All right, so we don't care about that one. We already know it. And again, we go back up, and what does Rolle's theorem tell us? It says that there's one value on the open interval. Okay, so it can't be part of the endpoints. Okay, so not part of the endpoints. All right, so remember, open interval means you don't include A and B. All right, so the only value that satisfies this is x equals 3. All right, of course, if you don't trust me, you can go back in here and substitute to make sure it does work. All right, so that's what Rolle's theorem says. It says that we go through, and if all three of these conditions are satisfied, which they are, that means there's at least one critical value, all right, within this interval 0 to 9 for this particular problem. All right, so we'll take a look at another one of these, and then we'll move on to the mean value theorem in the next video.